Alright guys, welcome to episode 3 of my coding vlog. Yeah, so this is what we ended up with last time. So yeah, it's not really a convincing 3D, right? It's somewhat a little bit wrong with it still, right? So what I've done is, first off, is the image was upside down. I'd made a mistake. So this half the height, I actually had plus half the height. So I've actually taken it away from, which is basically just flipped the image upside down again. So that works, and I've done the same with this y coordinate as well. And then I added an extra variable field, and I've replaced this with this, and I've done that on all the coordinates there. Basically what this does is it gives us a way of changing our field of view, so we can have a very narrow shot or a very wide shot, which changes the way the perspective looks. So you probably won't notice it much here. So to show it, I've gone into the design view and changed this key press, and I've double clicked, and it gives me this method, and in it I've put just basically, if we've pressed a W, then that field variable is added to, and if we press an S, we take away from it. I'm going to change these around a little bit. There we go. So yeah, with that, this is what we've got. Now, it's not getting further away and closer, it's just the camera being a wider shot or a narrower shot. But I can see some problems with that. So if you've got more of a complex shape, you'll see what I mean, and I'll show you that in a little while. But I added another drawline method, which basically takes the number of segments you want to divide the line into. So here we just find the size of each segment, and then we draw several lines connecting the first line, point A to point B, and we do each segment individually. Now what this does is quite interesting. So in our draw lines here, if we add some segments, and I'm going to put in two, in fact I'm going to put S. Alright, I hope I haven't got another. I don't think no. And then int S equals 2. So this is what we get. See the difference? Now again, things are looking pretty weird, right? But trust me, this is going somewhere. So if I do the same to this, the other square, see, it's further away, therefore it's got less of a curve. So if I just add a few more segments, say, I don't know, 6, why not? See, it appears to be a nice curve, and that works for me. So what I decided to do is add a complex object and see how that looks. So if we comment that out, and so these arrays I've set up here are just to store a load of points in this initialize objects method, and basically that just sets up a few objects, all the points for the objects, and I've got two variables here, -7 and a -14, and as you can see they are for the y variables, for the z variables, and you'll see why in a second. So where are we? Yeah. So then I draw each individual line. So let's grab this. So that just draws all my lines. Oops. There we go. So yeah. There we go. So if we change our field of view, have it something a bit more reasonable, it does look pretty cool, and it's a bit more convincing now that we've actually got a 3D object, a 3D view. So the lines aren't actually important for this particular project, so I'm not going to concentrate too much on drawing lines. So for the time being, while we're implementing rotations and translations and camera movement and stuff like that, I'm going to be using this object. So yeah, there will be a little bit more of a complicated object later on, but when we get into the 4-dimensional stuff, which is, you know, it sounds like a bit of a headache, but it's not that bad. So yeah, we want to get on now to rotations. So if we go to Wikipedia and search for rotation matrix, we come to this page, and here is a 2-dimensional rotation matrix, where basically all you do is you times the point as a vector and this rotation matrix, and you'll get your new point. But we don't want to work in 2D, we want to work in 3D. So we're going to go down to here, and we're going to take a look at this set of rotation matrices. So each one is a function. So if we want to rotate around our x-axis, we'll use this one. If we want to rotate around our y, this one. Rotate around our z, it's this one. And we give it the angle that we want to rotate it by, and then we multiply this matrix by our vector that we're trying to rotate. So how we do that is basically, let's say this is our rotation matrix and this is our vector x, y, z. What we need to do is multiply these two together. Now you can only multiply two matrices together if the width of the first one has the same amount of see, we've got A, B, C. So this is a 3 wide matrix. So this one needs to be a 3 high. So then what you end up with is a matrix that has the same width as this one and the same height as this one. So we know we're going to end up with one that's 1 wide and 3 high. So if we just draw that in there like that. So in our new matrix we're going to have 3 objects. So it's going to be the new X, the new Y, and the new Z. So to get our values from this, we look at the one that we're trying to figure out, and whatever position that is, we're going to rotate, we're going to multiply by its corresponding row. So it's the column multiplied by the row. So this first one will be X times A plus Y times B plus Z times C. And then this next one will be X times D plus Y times E plus Z times F. And this last one is going to be X times G plus Y times H plus Z times I. Okay, not the neatest, but you get the gist. So it's pretty simple, and that's how matrix rotation, matrix multiplication works. There's plenty of videos on YouTube. If you would like me to do an in-depth video about how to multiply matrices, then I can, do a little bit of planning and go through it properly. So yeah, if we apply that, if we work that out, we end up with this. So we've multiplied this matrix, these matrices, by the X, Y and Z vectors, and this is what we've ended up with. 3 new matrices that actually describe the rotations that we want. So then we need to convert that into code. So where are we? Here we go. So I've gone ahead and done that. Let me find it. Here we go. And that's how it looks like in code. So for the X rotation, we take a point and we take the angle, and then we return a new point. So if we're rotating around the X axis, the X itself won't change, just the Y and the Z will. And so if we look at this, so the X has been timesed by 1 plus no times Y plus no times Z. Then the Y is 0x plus cosine the angle times Y minus sine the angle times Z, which is what we've got there. And then this one here is no times X plus sine the angle times Y plus cosine the angle times Z, and that is what we have there. So if you're doing this yourself, don't forget these minus signs, so we can actually get rid of that plus sign there. So yeah, make sure that you've got all the minus signs. I'm looking at one right now and I'm just going to check there's a minus sign there. Yep, I've got that. So yeah, so the next thing we need to do is to be able to move the object around. So we need translate. Now, might as well just do this in one function. So point 3D translate point 3D p comma x comma double x double y double z, and then we can return new point 3D with p dot x plus x excuse me, and p dot y plus y and p dot z plus z. Easy. Okay, I'm going to do something really simple, because the important thing at the moment is that we've got these rotate and these translate things running before we start organising them in the way that they're going to be organised in the end. So at the moment I'm just going to do it here. I'm just going to first of all I'm going to rotate the object. A equals Rx A comma T, not this, tell you what, there we go, and so rotate xtx y and z, and then change this to y and z, and then translate A equals translate A comma, so we're going to want R x equals 0 comma R y equals 0 comma R z equals 0. So we're going to translate, so these are going to be the R's then. For rotate, and then these will be tx comma ty comma tz. So that works for me. So what I'm going to do is I'm going to put these as class variables so that we can access them, and what I'm going to do at the end of the onPaint method, I'm going to invalidate, which will force it to redraw. Once it's drawn, it will redraw the page, so we're going to actually get into some animation here. So this near and far, I'm going to change to my to 1 and -1. Actually, let's make it 5 and -5. Then what do I need to do? Yep. So I'm going to translate on the Z by -20, and when we invalidate here, now let's see what we get. So let's see. Oops. Yep. I know what's causing that. That's something I'm going to get onto soon, but that's fine for now. So yeah, let's get this to render a bit quicker as well, because that does look really, really bad. So it's rotating really quick, and I can tell you for why. I believe it's using radians, so we need to do a conversion at some point, but for now it doesn't matter. Where am I? Yeah. Let's try that, shall we? It's doing a lot of work. If it weren't for the flickering, it wouldn't look so bad. Let's see if we can speed it up a little bit, maybe. Well, we certainly can, but I won't be doing that at the moment. Okay, let's just have it as 2 segments. That looks a bit better. It kind of sends your eyes funny, but it is actually working. You can sort of see it. So let's make something else move around, shall we? That actually looks pretty cool. Yeah, I like that. I know it is pretty crude rendering, but that's okay. I think this is really going to work well. The longer you look at it, the more you can actually see. Yeah. See, I'm going to make it a little easier for you to see, and I'll be right back. Okay, so this looks a bit better. So yeah, it all works. I'm pretty happy with that. Nothing wrong with that at all. So yeah, that'll be it for this episode. I hope you enjoyed watching. I hope you learned something, or at least seen something interesting. So yeah, thank you for watching, and I'll see you next time. Bye bye.